Okay, so far we know how to do differentiation for individual terms. Okay, after you simplify. Yesterday what we did was, if there are two composite functions, we can make use of the product rule. Obviously, if you have product rule, the next thing is you must also have quotient rule. That means when we are given fraction, we may be able to make use of the quotient rule. But I need to alert you, it doesn't mean all fractions you straight away use quotient rule. I'm still waiting. Some of you are still stopping. I already say stop. I can't be waiting forever. Take a look at these two fractions. The first one, do you think you can differentiate without me telling you to do anything? Lisa, are you able to differentiate? How? Huh? Split. How do you split? When there are two terms on top at the numerator, one single term at the denominator, you can split. But this one is the opposite way. Can you split? Cannot. But what can we do? Okay, we can simplify. Agree? So if we want to do differentiation for this term, it's actually very simple. Bring down the power, reduce the power by 1, differentiate the term inside the bracket, you have 4. Agree? That is because the numerator is a number. So it's relatively quite easy. But now, if my numerator is not a number, it's an unknown. Likewise, I can still simplify it if you want to. But if you realize, this is not a normal differentiation. 2x itself is a composite function by itself. Agree? It's not the normal differentiation that we always do from step 1 to 3. It means that if this is given to you, you can make use of the product rule. But I must tell you, if you make use of the product rule, it's slightly longer. Can we do product rule for this one? We can, but it's slightly longer. That is why it's more purposeful to make use of the quotient rule. So I'm not going to teach you the product rule for doing this. But worst come to worst, if you are very unfamiliar with quotient rule, you don't use quotient rule, you can always go back to product rule. But I must let you know, product rule is longer. There is a higher tendency you may make mistakes. Okay? So today, we are going to make use and tap on the quotient rule because it's actually pretty fast. Alright? Quotient rule. Step number 1. Differentiate the top, keep the bottom. Minus. Step number 2. Differentiate the bottom, keep top. Step number 3. 3 steps up. Over the bottom square. Alright? So if you want to make use of the quotient rule, there are 3 steps to it. Okay, notice it's always very consistent. Even though Melissa did it the other way around. Melissa, take a look. Remember when you do your differentiation, you actually keep the first, differentiate the second, but I want consistency. The first thing you see, always differentiate first. I always see the first term, I differentiate the first term. I always see the numerator, I keep the denominator first. So I make it consistent. I won't get confused. Okay, that's why I want it to be done this way. Okay, ma'am? So far so good? Okay, I'm going to apply these 3 steps first to this question over here. Do we need to further simplify? No need. It's already in fraction, we can make use of the quotient rule. Now, if I need to do my differentiation, differentiate the top. So Kevin, differentiate the top, what do you get? 2. Navin, after that, what do we do? Keep the bottom. So I write it beside. Subtract. Ashwa. Subtract, differentiate the bottom. How do you differentiate the bottom? 4. Keep the. Remember, the thing is subtract, minus. There is a subtraction over here. Over bottom square. And we are done. We just need to simplify the numerator. So for quotient rule, it's much faster. But product rule, remember, after you apply the product rule, you still need to take out the common term, you still need to simplify, so there is an extra step. And after you simplify it, later you still need to bring it out to the numerator to make sure everything is in positive integers before you can start solving. Remember? So quotient rule is definitely more useful. After that, we simplify. 8x minus 8x, am I right? So there's no more x, so minus 6. Very neatly done. Okay? So I say again, why do we need to use the quotient rule? Because it's neat and fast. For solving a question, it's very fast. But I need to say this again. We will only use the quotient rule when required, meaning the top they are unknowns, the bottom they are unknowns. But in this case, if the top there is a number, no need to use quotient rule. But can we use quotient rule? Can we use quotient rule? There's nothing wrong. But you got to slap yourself very long. If let's say I use quotient rule for this one, no problem. Let me show you. Differentiate the top, what do you get? 0. That's why 0. But I can tell you a lot of y'all differentiate the top, sure right one. Okay, that is a common mistake. 0 1, no need already, right? No need to keep the bottom. Sure 0 1. Minus, differentiate the bottom, what do we get? 4. Keep the top. Keep the top 2, right? Over bottom square. Do we get the same answer? Huh? No, man? Same, huh? Correct, right? So even if you want to use a quotient rule for this one, it is still going to be okay, but not necessary. Just tell yourself, Mr. Yu, you say, oh, if it's just a number, use normal, simplify and differentiate. Unless there is an unknown, and we're going to practice this today. So the thing now is, you must tell yourself, differentiation is not difficult, so long you know how to simplify. Alright? Please copy down the steps and copy down the examples.